NASA says it's Explorer 1 the most far-off human-made object in the universe is sending usable data to Earth. Again, in the universe we have no thought what it is except for we can gauge it. Explorer 1, the notorious space test sent off by NASA more than 4.5 many years ago, has recently conveyed back a message that has sent shockwaves through the academic community. Subsequent to traveling almost 14 billion miles from Earth, Explorer 1 has made a discovery so significant that it has modified the direction of its mission, turning around towards our planet. Join us on this grandiose journey. 7 minutes ago, Explorer 1 made an alarming discovery, turning around to Earth. But what exactly might this revelation be? Could it be proof of extraterrestrial life, a vast oddity, or something even more unfathomable? In this gripping investigation, we will uncover these stunning discoveries as Explorer 1 just made a startling discovery that made it suddenly turn around towards Earth. History of the Explorer twin tests. If certain divine events hadn't harmonized, two of the most amazing rockets ever sent off may very well never have left Earth. For this case, it were the 4 biggest planets to align in our planetary system around 60 years ago. These planets were slowly aligning in a manner that had last happened during Thomas Jefferson's administration in the mid-19th century. This intriguing planetary arrangement went largely unnoticed at first. The first person to recognize its importance was Gary Flandreau, a doctoral student in flight at the California Institute of Technology back in 1965, when space exploration was just beginning, working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California. Flandreau was entrusted with sorting out the most efficient method for sending a space probe to Jupiter, or even farther away to Saturn, Uranus, or Neptune. Using a simple pencil, he carefully plotted the orbital paths of these giant planets and made an interesting discovery. In the late 1970s and mid-1980s, all 4 planets would align in such a way that they could be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to slingshot itself to the next, essentially reducing travel time. Flandreau determined that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, there was a catch. This planetary arrangement only happened once every 176 years. To exploit this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built 2 spacecraft to make the journey: the Explorer 1 and Explorer 2. These twin spacecraft were sent on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment of the planets and the visionary calculations of Gary Flandreau, the launch of the Explorer twin probes on September 5, 1977 was something truly remarkable. At a place called Cape Canaveral in Florida, Explorer 1 embarked on its incredible journey into space, launched by a powerful rocket known as Titan III, or Center. Only 15 days later, Explorer 2 was launched on August 20th, 1977. Explorer 1 began its journey into the vast universe, following a shorter path. Their primary mission was to explore the gigantic gas giants in our solar system, such as Jupiter and Saturn, along with their numerous moons. However, these courageous space voyagers surpassed all expectations. They ventured far beyond, pushing the boundaries of exploration, traveling farther and longer than any other spacecraft in history. They broke several records on their inspiring odyssey. They ventured beyond anything made by humans before even entering a region known as interstellar space, a completely unknown area within our galaxy. These exploratory spacecraft, Explorer 1 and Explorer 2, are now more than 12 billion miles from us despite their enormous distance they continue to astonish scientists with the amazing discoveries they make out there most. Recently, they have made a discovery so startling that it has taken everyone by surprise. The Explorer twin probes have accomplished several truly remarkable feats. Years ago, they studied the moons of Jupiter and Saturn, surprising scientists who initially believed them to be dull and pitted like our own moon. These moons turn out to be lively hubs of activity. Explorer made history by becoming the first of the twins to swing by Uranus in 1986, and just 3 years later, it zoomed past Neptune, an accomplishment unequaled by any other spacecraft. As these spacecraft continue their complex journey, NASA used some clever strategies to ensure they stay functional. They've deactivated unnecessary parts like extra components and heaters to conserve power. The plan is to keep the spacecraft operating until at least 2025 for the dedicated scientists and engineers who have been part of this extraordinary journey from its inception. It is a mix of emotions. Their hard work has paid off, and just when they thought the Explorer missions were nearing their end, a shocking discovery emerged from the depths of Space Explorer's revelations. Asterisk at the start of their incredible journey 40 years ago, the Explorer spacecraft amazed experts by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers had believed to be dull and heavily pitted like our own moon, turned out to be dynamic worlds. Explorer 1 reached Jupiter in March 1979, only 546 days after its launch. Explorer 2, following a slightly different path, arrived in July of that same year. Both spacecraft were equipped with special cameras that use filters to capture full-color images. Interestingly, they were designed to be very steady, rotating through space at a rate more than 40 times slower than the hour hand of a clock. This ensured that the images they captured were clear and sharp during their mission. The Explorers took more than 33,000 photos of Jupiter and its moons, each revealing new and fascinating details. For example, Europa, one of Jupiter's 53 named moons, was found to have a cracked, icy surface, estimated to be more than 60 m thick. As the spacecraft departed from the Jupiter system, they received a speed boost of 35,700 miles per hour from a gravitational slingshot, a critical maneuver that propelled them toward interstellar space. At Saturn, the Explorers went their separate ways. Explorer 1 passed through Saturn's magnificent rings and endured thousands of impacts from tiny dust particles before flying by Titan, a moon surrounded by an orange haze, and traveling north out of the plane of the planet's rings. Explorer 2 continued its individual journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Explorer 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Explorer 2's achievements were overshadowed by tragedy. Only 4 days after its closest approach to Uranus, the space shuttle Challenger tragically exploded shortly after liftoff, killing all 7 crew members, including Chris McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian in space. 3 years later, as Explorer 2 flew over Neptune's stunning sky blue methane atmosphere, it encountered the fastest winds recorded on any planet in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, turned out to be one of the coldest places in our solar neighborhood, with surface temperatures plunging to a staggering minus 23.35 degrees. The moon's frozen volcanoes were another remarkable discovery, shooting nitrogen gas and fine particles up to 5 miles into its atmosphere. After Explorer 2's captivating images of Neptune and Its moons, both spacecraft, were scheduled to shut down their cameras, marking the end of their official mission. However, astronomer Carl Shawn, a member of the mission's imaging team, intervened. Despite the mission's official end, NASA extended the mission with hopes that the explorers would venture into interstellar space. Renamed the Explorer Interstellar mission, the spacecraft were set to continue their journey into the unknown. Explorer 1's interstellar journey asterisk. In August 2012, Explorer 1 achieved a stunning milestone by venturing beyond the heliosphere, a vast region of charged particles created by the Sun. This surprising achievement became widely known the following year when a study was published in the journal Science, sharing Explorer 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a strong solar flare between April 9th and May 2013. This event caused electrons near Explorer to vibrate, indicating that the spacecraft had entered a region of higher particle density than that found inside the heliosphere. At first glance, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers explain that the electron density at the edge of the heliosphere is significantly lower than on Earth's surface. By analyzing Explorer 1's data, scientists pinpointed the spacecraft's exact flight date as August 25, 2012. This determination was not based solely on electron movements, but also on measurements of charged solar particles collected by the spacecraft on that important day for the Explorer team. This announcement was a source of immense pride and satisfaction. Susan Dodd, the project director, expressed the team's excitement, saying, "We are thrilled to have been able to keep working with the explorers and to see it achieve the incredible milestone of entering interstellar space." Ed Stone, a key figure in the Explorer missions from the very beginning, emphasized the significance of this achievement in advancing our understanding of space. He said, "Explorer has led us to new discoveries by giving us the first view of this new region, expanding our scientific understanding of the nature of energy and radiation in space." Explorer 2 also crossed into interstellar space in November 2018, venturing into an unknown area beyond the Sun's protective bubble, which shields us from cosmic radiation. However, the truly astonishing news comes from Explorer 1 after an incredible 46 years. NASA's Explorer 1 spacecraft, the most far-off human-made object in space, continues to send valuable data back to Earth despite its unprecedented of over 14.7 billion miles. The spacecraft remains functional, although its primary mission has long since concluded. However, here's where things get really exciting. Explorer 1 has recently made an extraordinary discovery that has left scientists both baffled and deeply concerned. As Explorer 1 traveled through space, something unusual occurred. It began sending data back to NASA, revealing an anomaly in its trajectory. The data it received indicated signals containing information about an unknown phenomenon that defied explanation. This anomaly seemed to suggest a massive, previously undetected object exerting a tremendous gravitational pull, distorting the spacecraft's path. This discovery has shaken the scientific community to its core, sparking a whirlwind of speculation. Could it be a rogue planet, a black hole, or something entirely phenomenal? The implications are staggering if confirmed. This newly discovered object could challenge our fundamental understanding of the universe. NASA has assembled an emergency team of scientists to investigate further, using all available resources to analyze the data and potentially divert Explorer 1 to gather more information. This startling twist in Explorer 1's journey serves as a reminder of the vast mysteries that lie beyond our planet and the enduring spirit of exploration that drives humanity to seek answers in the far reaches of space. The spacecraft, equipped with 3 radioisotope thermoelectric generators, had an expected operational lifespan of 4 to 12 years. Remarkably, Explorer 1 has far exceeded expectations, continuing its mission for an incredible 45 years. Unlike solar panels, these radioisotope thermoelectric generators produce power through the heat generated by the radioactive decay of plutonium-238. Despite this remarkable perseverance, NASA estimates that by 2025, the Explorer spacecraft may no longer be able to generate enough power to operate its instruments and transmit data back to Earth. During routine communication with Explorer 1 via NASA's Deep Space Network, something extraordinary occurred. After more than 40 years of continuous data transmission, NASA's computers on Earth began receiving an unusual signal that left everyone concerned. For the first time in its mission, Explorer 1 suddenly halted its journey and performed a complete 180 degrees turn